Hello, and welcome to this first major portion of preparing for the CSET in mathematics. We are going to be looking at the number system, and number sense is the way the CSET refers to it. Number sense in these first few videos and first few lessons in the course. And today, specifically in this section, we're going to be talking about the decimal number system, our number system that we use. And it is called the decimal number system, but it's also called the base 10 number system. And if you think back in history a little bit as to why we would use a base 10 or a decimal number system. For example, well, I'm sitting in a computer lab right now, and computers use a base 2 number system, which means that they only have 2 digits in their number system. Those digits are 0 and 1. Because all a computer is a bunch of switches inside. And so either a switch in a computer is on or a switch in a computer is off. And that's all it knows. And that's how it does its calculations and so on. And so why do we as humans use a base 10 or the decimal number system? Now as you're thinking about that, you can't say that it's just because it's easy. It's only easy because that's all you've known all your life. Ever since you were a little toddler learning how to count, that's what you've been using. And so it'd be like saying English is I don't know why we would say this, but English is the easiest language only because we've been learning that all of our lives. And so you can't use that, but think back a little bit further in history as to why we would use a decimal number system as humans. So let's think back to the beginning of time and creation in the garden. And so God has created animals, and then he has created Adam. And he has given Adam a specific job to name all of the animals. Scripture tells us that specifically. And so just picture that process. And so he's going around the garden and he is naming animals. And in that process, I'm sure he's starting to keep track of those animals and starting to count them. Well, what does Adam have to count with? That's right. He's got his fingers and his toes. And God created us with 10 fingers, and so that's what Adam used to start creating or start counting things as he went. And so let's picture that process. So he's going through the garden. He sees a camel. That's number 1. He sees a zebra. That's number 2. He sees a hippopotamus and names that. That's number 3. And so on. This process continues, and as he starts counting those things on his fingers, he runs out of fingers. And as the old joke goes, in order to count above 10, you're going to have to pull off your shoes. And when he got to 10 and ran out of fingers, he started counting toes, and each toe would represent tens of things. And as he kept going with that and getting to 100 items, then he would need something else. Maybe a stick to represent 100, or a rock, or whatever he might find there. And that is the basis of our number system and how we carry over into the next thing. If we run out of fingers, we carry over into toes. If we run out of toes, we carry over into sticks, and so on. And so as he was counting those animals, that's the process that he used. And that's because we have 10 fingers, that's why we have a decimal number system, or a base 10 number system. So as we look at that, let's write just a general number that we would all be familiar with here. So let's look at just the number 472, just as an example of our number system here. Okay, and let's keep going with our example of Adam in the garden. And so this number right here, this digit, would be the fingers place, right? That's what he started counting with. And so this is the fingers place, but we refer to it as the ones digit, right? And so again, as he ran out of fingers, then he carried over. So when he got to 10, he carried over to toes. And so this digit right here would represent the toes place, okay? Or the tens place, so that when he carried over from ones, he would carry over into the tens. And so that would count 10, 20, 30, 40, and so on. Okay? As he progressed from there, again, he would have to get to a stick or a rock or something to represent hundreds. And so this decimal place right here, let's call it sticks. say that he used a stick to represent the hundreds. And so this is the hundreds place. Okay, and so on. As he continued to count, again, if he used sticks here, maybe use rocks for the thousands place, 10,000s place, 100,000s place, millions place, and so on. And so that's how our base 10 number system began. And that's how we count things. And so everything is based on tens as we progress. Now, one of the reasons why it's called a base 10 number system is because as we look at these ones, tens, hundreds, and so on, again, each one of them is a multiple of 10 as we progress across from to the left as we go. Okay? And so let's write this just a little bit differently. So as we look at the ones place, as we look at this place right here, as the ones place, this is also 10 to the 0 power. Now we're jumping ahead a little bit here in terms of what we're covering, but anyway, 10 to the 0 power. Well, literally you can't multiply something by itself 0 times, and so this is actually a definition in math. We have to define this way or else our other powers won't work correctly, and so we define anything to the 0 power to represent 1. And so 10 to the 0 power is 1. Okay? And then we can have a multiplier in there of how many ones we have. Okay? Then as we progress over here again to the tens place, we end up representing that as 10 to the first power. And anything to the first power is always itself. Okay? Essentially you're multiplying it by itself once, and so it's just itself. And so the tens place is 10 to the first power. The hundreds place here is multiplied by one more 10. Right? And so this is 10 squared. And if you think about 10 squared, again, that power up there means how many times you multiply the base by itself. And so this would be 10 times 10. And so 10 times 10 is 100. And that's this hundreds place here. And again, if we were to continue on and let's say that we had a 5 over here, well, this thousands place is what it would be called. The thousands, how many thousands do we have? Well, that's 10 to the third power, because 10 times 10 times 10, 10 times itself 3 times, is 1,000. And we continue in that. This would be 10 to the fourth, 10 to the fifth, 10 to the sixth, 10 to the seventh, and so on. Okay? And it ends up being, if you were to write just that number, it would be 1 with that many zeros behind it. Okay? And so this is why it's called a base 10 number system. Okay, we use that base down there and raise it to the different powers in order to get how many numbers, how many items that we're counting within that process. All right? Now, most people are okay with this. Most people are okay with our number system as we progress to the left in our decimal number system in terms of representing the numbers as digits. Most people understand the concept of ones, tens, hundreds, thousands, 10,000s, 100,000s, and so on. Most people are okay on the left side. Okay? Some people start to get confused when we go to the right in our number system. And as we move to the right, what I mean by moving to the right is, let's look at this again a little differently. What I mean by moving to the right is that there's an unwritten decimal point here. And we call it a decimal point because it is our decimal operating system. And so when we move to the right, now we're talking about parts of things. And that's the way you need to think about things to the right of the decimal. They are parts of whole numbers. So, not to get too graphic here, or not to offend any vegetarians or whatever in our group, but the way God created animals is they eat other animals. And so maybe Adam is walking around the garden counting these animals, and let's say that he wanders upon a hyena that has taken down a little antelope and is partially eating that antelope. And all of a sudden a lion comes along and scares off that hyena. And so there is part of a antelope there. Okay? Sorry, I don't mean to get too graphic here, but let's just say that there's part of that. And so for whatever reasons, Adam is counting that as a part. Okay? And so let's say that he estimates that to be half of the antelope is left. And so there's a 5 there. because this place right here is the tenths, 1/10 of a whole, and if he is considering half of that animal to still be there, then that would be 5 out of 10, which 5 out of 10 is 1/2 of those things, and so that would be 1/2 of that animal. And so now he's just estimating that. You know, there's no way that he would know that just by estimating, that there's not 52 hundredths of an animal there. Okay? And so this number would represent 52 hundredths. And as we continue on, this number out here would represent thousandths and 10,000ths and so on. Basically, they're named the same as to the left, except they have a THS at the end. Okay? And we continue with our base 10 number system. We continue with that process of this being 10 to the 0, 10 to the first, 10 squared, and so on. It's just that we're going backwards. And so this actually is represented as 10 to the negative 1 power. Now again, we're jumping in concepts here because we haven't talked about exponents yet. But a negative 1 power, all that means is that that represents a fraction. And so what this literally represents is 1 over 10 to the first power. And we don't typically write 1 as a power. We're lazy as mathematicians, and so we don't write powers that we don't need to, or numbers that we don't need to. And so that just literally means 1 over 10. Okay, this base goes down to the bottom of a fraction is what the negative means. And so if we do that over here, if this is 10 to the negative 2, maybe I should put these back in again. Okay. As we go backwards this way, this is 10 to the negative 1, 10 to the negative 2. That literally means 1 over 10 to the positive 2. Well, what is 10 to the positive 2? That is 100. So this is 1/100th here. Okay. The thousandths, I didn't write it here, but this decimal place here, I'm probably in the way now. This place right here being the thousandths place. Okay. That represents 10 to the negative 3, which again is 1 over 10 to the positive 3, which means 1 over 1,000. And so that's 1/1000th. In this case, we have 3 1,000ths being represented there. All right? And so this is the base 10 number system. Okay? And again, it continues on in each direction forever. Each of these numbers represented or each number that could be represented here is an infinite concept. And so again, we can keep going that way. We're at thousands here. We could go to 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, and we just keep going and going and going. Same thing here. We can go tenths, hundredths, thousands, 10,000s, 100,000s, millionths, and so on, forever that way also. And so this is the way that our decimal number system works. Okay? And so it keeps going in either direction. Now, let's try to convert this concept here to something that we're a little bit more familiar with. Again, some people get confused once we start going to the right of the decimal. And so let's change this a little bit. And let's kind of switch over to something that we might be a little bit more familiar with. Okay? Let's consider this to be, in our decimal number system, let's look at the way that we represent money. Most of us are familiar with handling money, counting money, those kinds of things. And so let's say that we, within money though, let's say that we limit ourselves to very specific ways of counting money. Okay, and what I mean by that, we're gonna limit ourselves to dollars, or however many dollars. We could be in the hundreds of dollars or whatever. Dimes and pennies. Okay, so what I mean by limiting ourselves to that, we're not going to be counting things by methods of quarters or methods of nickels. So no quarters or nickels here. We're just looking at dimes and pennies for this particular example that we're doing. Okay? And so let's represent a dollar amount. And so if we had $4.68, okay, this is the way we need to think about this. This is dollars, right? And so this does represent whole units, because our money system works based on the dollar. And so these are whole dollars right here. Okay? The digit to the left of the decimal place is a whole thing that we're talking about. In this case, it's dollars. Here we're talking about how many dimes we have. Okay? Because again, we don't have quarters or nickels for our example here. So we have 6 dimes represented here. Because a dime, how much is a dime? 1 dime equals 1/10 of a dollar. Right? Because it takes 10 dimes to make a dollar. And so 1 dime is 1/10 of a dollar. Right? And so that's what that digit right there represents. How many dimes we're representing is how many tenths of a dollar we have. If we end up having 10 of those, then we have another whole unit. We have another dollar. All right? And here is representing our number of pennies that we would have. And again, no nickels, we're just dealing with pennies. Well, that represents pennies because 1 penny equals 1/100th of a dollar. Right? Because it takes 100 pennies to make a dollar. So if we got to 100 of these things here, we would wrap over to one whole unit again. Okay? And so the number of pennies that we have, if we get to 10 pennies, we can convert that to a dime. And we roll over to the next decimal place. If we end up with 10 dimes, we can convert that over and roll it over to 1 full dollar in the next decimal place. Now, the way this is read is $4.68. But just in our decimal number system, the way this is read is 4 68/100ths. Okay? That may be thinking of it as 68 pennies. Okay? So we know that this decimal point is what represents the split between whole numbers and parts of numbers. It's just that these parts over here, however far it goes, are always in tenths of the next unit that we're talking about. All right? So that is our decimal number system. And that's the first main concept on the CSAT, that you need to make sure that you understand how our decimal number system, how our base 10 number system works. And so we'll look at some practice with this, and we'll look at some quiz questions that might be examples of the CSAT, and move on to our next unit. So we'll see you in there. Thanks.